And now when I run this, we're going to step into the meshgrid function, which is defined right here at the bottom. And this function takes as arguments our 20 by 20, and then our index 2. So let's get into this. And we'll jump right here. Now, before we start going over the meshgrid function, I just want to share one thing here. So as we know, this is our new shape. And you can think of this as 3 tensors, each of them of a 20 by 20 by 85. So it's a 20 by 20 by 85 tensors, and we have 3 of them. So in theory, they're one after the other, continuous, but I like to visualize it as 3 of them because it's easier to visualize 3 dimensions, but this is a different way of seeing it. We have 3 tensors, each for each anchor, and each tensor has this shape. And again, the anchors are these ones. Because we are in index 2, 0, 1, 2, these are 3 anchors, 1, 2, and anchor 3. Of these predictions, we have 3 anchors. We have 85 here times 3, and it's a 20 by 20. So I personally like this visualization. Now here, we're just going to define the device and the type. So we have D and T, and we've created this shape tuple of 1 by 3 by 20 by 20 by 2. Now we're going to do a parallel path between VS Code and, as we've done before, our Colab environment. So the first thing that we're going to do is call torch.arange 20 for both Y and X. Here is just defined as Y and X because it's called within a function. But because we're calling it here in our Colab environment outside a function, I'm just renaming them so we don't override the values Y and X. And arange 20, given that we're only providing one input, we will return a 1D tensor with values from the interval 0 to 20, including 0, but not including 20. So from 0 to 19. And they're the same because, well, we have the same values here. So we can run that, and we obtain the same values. And now we're going to call torch.meshgrid that creates grids of coordinates. So in this case, the tensor that we're providing is first Y and then X. And then here we're also providing the argument indexing IJ, but we don't have to include it since it defaults to IJ. So let me run this first here. And you can see that the Y tensor changes on the Y component and then remains the same on the X component. So the Y changes while the X tensor or XV changes on the X component. So the inputs here were identical, but for naming convention, the Y was first, and then we have YV first and then XV second, where again, Y changes vertically and X changes horizontally. We can run this here as well. And now we're going to unwrap this line of code here in our Colab a little bit more. So let's go here. And what we're going to do is stack XV and YV. And we're doing that with torch.stack that concatenates a sequence of tensors along a new dimension. And then, of course, all tensors need to be of the same size. So our dimension is 2, and our tensors are XV, YV. So if you see here, XV starts with 0. So XV, YV, so our first value will be 0, 0, and then 1, 0, and then 2, 0. And then once we reach 19, 0, well, the next one will be 0, 1, and so forth. And given that we have this value 2, these will be pairs or coordinates where each value will be a pair. And these tensors are 20 by 20, each of them. But when we stack them, we'll create a new tensor of 20 by 20 by 2. So you can see that 0, 0, and 1, 0, 0, 0, 1, 0, and so forth, all the way to 19 by 19 here at the bottom. Now, this tensor is a 20 by 20 by 2, but we want to expand it to the shape of the variable shape. So we want to expand it to 1 by 3 by 20 by 20 by 2. And this is easily done with the .expand method, which returns a new view of the tensor with the dimensions expanded to this larger size. So the values will remain the same, but what this method will do is that it will create these extra dimensions that currently do not exist. So let me run this. And you can see that here we have these 3 dimensions, this 20 by 20 by 2. And now we've expanded the dimensions to 1 by 3 by 20 by 20 by 2. So we can also visualize this with this helper function that was defined in this section here above, and we previously ran it already. So basically, if I run this, generate grid, this is what we obtain, and this is what we just created, a 20 by 20 grid. And you can see that these coordinates, X and Y, correspond to the top left corners of each grid cell. So given that an image, and in this case, this is a small version of the image, so 20 by 20 grid, an image has the X component going left to right, and the Y component going top bottom, where the coordinate 0, 0 will be right here. And for example, the coordinate 1, 0 will be here, and A2 would be here. This is, we just created a mesh grid of these values.